So today's lesson is a little different. This is one of those situations where you're going to have activities instead of practice questions. So the activities are exactly like this activity I'm about to show you. You'll do 2 of them, and that will be it for today. So within this lesson, once you get to the questions, it will give you a link and you'll go to pages that look exactly like this. So I'm going to just click this to give myself some more space, but you don't have to do that when you're doing the questions. So I'm going to try to make this a little bigger for me. So what we have going on here is called a Venn diagram. So we've got some circles with labeling information, and then they're overlapping in the middle, and then I've got all my shapes down here that we'll deal with later. So what we need to do is take each of these shapes, and you can move them by clicking on this little dot on the corners of each of them. They all have a dot. Is we're going to move them into the correct location in terms of the Venn diagram. Now there are multiple locations these things can go, and they can go in this side, the middle, the other side, or even the outside could be a location. So let's just kind of start diving into this. The first part says has at least one pair of parallel sides. So parallel means if you were to extend those sides, they would never touch each other. Then the next one on the other side has at least 2 sides of equal length. So let's take this first one right here. Does it have parallel sides? These 2 sides would cross each other at that point, so that's no. These 2 cross at this point, and then these 2 cross at that point. So no, it does not fall within this location, so it also will not fall in the overlap. And then it says has at least 2 sides of equal length. We have this side and this side. So this is actually an isosceles triangle, and we're going to put it in that location. Now the next one, we've got this shape is a square. So it says has at least one pair of parallel sides. It has one set here on the top and the bottom, but it also has another set on the left and the right. So at least one pair says one or more. So this definitely has one or more. So it will for sure go here, but let's see, does it have at least 2 sides of equal length? It also has 2 sides of equal length. It has more actually. So we're going to put it in the middle. All right, next shape. This is a rhombus, so that means all of these sides are equal. Some people like to call it a diamond. We know that has a pair of parallel sides, this slant and this slant. If you were to extend those, we would never touch. But then we have this other set over here too. So it definitely would go into this one. Now let's see, does it have at least 2 sides of equal length? Yes, it actually has more. So it's going to go in the overlap. It's going to do both. So now let's look at this next one. This has 1, 2, 3, 4, 5, 6 sides. So that means it is a hexagon. And in this picture, it's a regular hexagon, meaning all sides and angles are equal. So it says has at least one pair of parallel sides. The top and the bottom would never touch each other, but an example of a set that would touch each other, let's say, are this side and this side. Because if I were to take this side and extend it all the way down, it would end up down here. And then same for this side, and they would cross somewhere right here. So although it does have one set, not every set of sides are parallel, but we only needed at least one pair. So that definitely goes, that definitely goes here. And then it says has at least 2 sides of equal length. Since this is regular, and that means all the sides are equal, so it's going to go in the overlap. And my shapes are going to be too big, so I'll just leave them in overlapping each other. So then we've got this shape right here, looks like an isosceles trapezoid, meaning these 2 sides are equal and it's a trapezoid. So it says has at least one pair of parallel sides. The top and the bottom are parallel, they would never touch each other. And it also says has at least 2 sides of equal value. The left and the right side are equal. So I'm going to put that in the overlap. Try to fit that in there. The next one we have is a kite. Kites have these sets of sides equal and these sets of sides equal, but we don't have any parallel sides. So that's just going to go into the right side here with at least 2 sides of equal length. The next one we have is a rectangle. We have parallel sides on the top and the bottom. That's one pair. And then the left and right, that's also another pair. And then 2 sides of equal length, we've got 2 sets of 2 sides of equal length. So that's going to go in the overlap. Then the next one we have This right here, I'm not sure if you would notice what it is, but if it was rotated, it would look like a trapezoid. And it is a trapezoid. It's just rotated to where it kind of looks different than you're used to. But a trapezoid, the definition is one pair of parallel sides, and I have the left and the right here are parallel. But then I don't have any sides that are of equal length, so I'm going to put it on the left side. And then this one right here is scaling triangle because none of the sides are equal. And we know that looking at all the sides, if it's a triangle, none of them are going to be parallel because they'll all intersect each other. So we're going to keep it on the outside of our shape because it doesn't fit within any of these parameters. This one right here is a right, 90 degrees would go right here, and then isosceles because these two sides are equal, triangle. So we know it doesn't have any parallel sides, but it does have two sides of equal length. So I'm going to put it over here. And then let's get the next one. This next one is an equilateral triangle, meaning all the sides are equal. But if I think about parallel sides, none of them are parallel. So it does have at least two sides that are equal. More, at least remember means could be more, but it has to be minimum 2. And then this one is a quadrilateral. Although these sides look almost exactly equal, they are not. Quadrilateral, the definition is it just has to have 4 sides. They don't have to necessarily be parallel. You don't have to necessarily have sides of equal length. So this is going to stay on the outside. It doesn't fit within any of those. This next one is a regular pentagon. So 1, 2, 3, 4, 5. All the sides are equal and all the angles are equal. So when I look at this, I'm trying to find a set of sides that are parallel, but when I start drawing them, start extending those sides, what happens is they all intersect each other. So none of the sides will be parallel. This says has at least 2 sides of equal length. Well, all the sides are equal, so it's going to stay in this right one. 3 more, and then you get to do some practice. Okay, so the next one is a parallelogram. Parallelogram, what's nice about that is it's got a set of parallel sides, both of them, because the name is parallelogram. And then we know that these sides are equal, the top and the bottom, and the left and right are equal. So that's going to be in the overlap. When you are doing this, try to make sure that you're not like doing something like that. Make sure hopefully it's within its space. I know they don't all fit perfectly, but do your best. All right, the last 2 here. Oh, I just realized this is a right trapezoid up here. Hold on, that's a right trapezoid because I have right angles. This is just a trapezoid alone, and then we had an isosceles trapezoid in here. So a trapezoid has to have parallel sides. It doesn't have to have equal. It doesn't have to have equal sides though. And then the last one is a right triangle. It doesn't have any parallel sides, and it also doesn't have 2 sides of equal length. So that's going to go on the outside. And technically, this could go anywhere on the outside, but I'm just going to put it next to the other ones on the outside. All right, go do some practice.